Okay, let's try factoring some numbers. Let's take a look at 8 and 15, okay? And let's factor 8 and 15 out. Let's break them down into prime numbers, and then let's find the greatest common factor of those two numbers, okay? Well, first of all, I could just list out the factors of 8 and 15. 8 has 1, it has 2, 4, and 8. 15 has 1, 3, 5, and 15. And so there's 4 factors of 15, and there's 4 factors of 8. So I'm looking at these factors, and the only factor I'm seeing in common is 1. Okay, let me try a factor tree just to make sure. We've got 4 and 2, and 2 and 2. Well, I know 2 doesn't go into 15. So I'm going to assume at this point that 1 is the only factor that they have in common. So their greatest common factor between 8 and 15 is 1. Well, that means that the two numbers are something called relatively prime. Relatively prime means the greatest common factor is 1 between the two numbers. Think of prime. Prime numbers got nobody but 1 in themselves. So prime means that that a number only has 2 factors, 1 in itself. Well, relatively prime, a relative is somebody you're related to. So that means that there's more than one person. Well, relatively prime, you can think that there's a relative, that this number has another friend, a family member, and they're relatively prime. So the only thing that they have in common is 1. It's 1. All right, so let's try number 2, 27 and 45. I'm going to break these down into a prime factorization tree. Actually, I'm going to go ahead and list the factors first. Sometimes listing the factors for larger numbers is not the best way to go, just because there are so many factors of a large number, and you're likely, the larger the number is, the more likely you are to miss some factors as you're trying to list them out. But I know 1 is a factor of 27. I know 3 is a factor because of my divisibility rules. I know that 9 is a factor. I know 27 is a factor. 1, 3, 9, and 27 are the factors for 27. So 27 has 4 factors. Let's try 45. I know 1 is a factor of 45. I know that 3 is a factor of 45. I know that 5. I know that 9 is a factor of 45. I know that 15 is a factor of 45. I know now that 45 is the factor of 45. So that's 1, 2, 3, 4, 5, 6 factors of 45. And I'm looking to see if they have any in common here on the factor tree. And right now, the only thing I'm seeing is 9. Well, let's see if I can find that same factor by breaking it down in a prime factorization tree and looking for their common prime numbers. Because like I said, the larger the number, the harder it is to find all of the factors of that number, and you may miss something. So a prime factorization tree is the best way, especially with larger numbers, to find the greatest common factor of the two numbers. You can't miss you can't miss all of the factors in a factor tree, but you can accidentally skip one if you're listing them out. So let's see, 9 times 3 and 3 times 3. And then for 45, we have 5 times 9. and 3 times 3. So I'm going to circle my prime numbers. And I have 2 3s in common on both trees. 3 times 3 is 9. So I only write what they have in common one time. And so their greatest common factor is 9. Okay, on this slide you are going to pause the video and you're going to try these out. You're going to find the greatest common factor in all 3 of these scenarios. All right, to find the greatest common factor of 49 and 21, I'm going to break this down into a factor tree. So I'm looking at 49. I'm going to ask myself, what number do I know goes into 49? Well, 7. And 7 times 7 is 49. So on my prime factorization tree, I have 2 7s. And for 21, I know that 7 times 3. And those are both prime numbers. And so looking at this tree, they only have one number in common, and their greatest common factor is 7. G, C, F, 7. Number 2, I have 13 and I have 32. Well, 13 only has 1 and 13 as factors. So 32 would have to have 13 as a factor, or the 2 numbers are going to be relatively prime. So let's try this one out. Let's see, it's 2 and 16. And 16 breaks into 4 and 4. And the 4s will break into 2 and 2. But they have nothing in common with 13. So I can say that 13 and 32 are relatively prime. All right, we have a word story. Number 3, Morgan is making goodie bags for her little cousin's birthday party. She wants to distribute the 28 candies and 44 whistles equally with none left. How many bags can she make? All right, so we're looking for bags. That means groupings. And we're looking for equal amounts and for nothing to be left over. So we have 28 candies and we have 44 whistles. So let's take those 2 numbers. Since we know we're looking for a grouping, and that tells me I'm looking for a smaller number, I'm going to be looking for the greatest common factor, the largest number that divides evenly into 28 and into 44. So I'm going to break these down into factor trees, find the prime numbers on both, and find what they have in common. Again, on this factor tree, they both have 2 2s in common. So I write down what they have in common only once, and I find that Morgan can make 4 goodie bags